This is case 2 in general. Z is raised to the power p over q, where q is an integer greater than 1, p is a positive or negative integer, not 0, and p and q are relatively prime. In other words, the greatest common divisor of the two is the number 1. And this power function is defined for every complex number z except 0. So previously we saw that if we have z to the power 1 over q and we define r as the absolute value of z raised to 1 over q, then a typical root would look like r times e to the I theta. To get all the others, we keep adding 2 pi over q to the arguments. So in other words, we divide 2 pi by q, and that gives us the difference between two consecutive arguments. So this angle from here to there is 2 pi over q. So by adding 2 pi over q to the argument theta, we get the next cubed root of z, and so on. Now, to get z to the p over q, we have to raise every one of these roots to the power p. So the question is it possible to take two different roots and raise both to the power p and get the same complex number?